Okay, in this video, we're going to talk about how to correctly balance a ratio between ionic compounds. Now again, an ionic compound is a compound that's formed between two ions. An ion is an atom that has a charge. Now, the ions, to begin with, may have charges, but afterwards, the ionic compound will not have a charge because they cancel each other out. So for example, here, I have sodium and I have chlorine right here. Each one of them, to become stable, will have a charge. So sodium will have a positive charge because it gets rid of an electron, and chlorine accepts that electron, so it becomes negative. So that's why they become stable like this. Now, in order to us to correctly balance them, we have to balance those charges. Those charges are balanced once the base numbers are the same. Now the charges will be opposite, and they need to be opposite to cancel each other out, but the base number is the same. So I have a positive 1 here. I know a 1's not listed there, but if there's no number, it's automatically 1. So there's a positive 1 and a negative 1. Well, in this case, the base number is the same. So the positive and the negative cancel each other out. So for every 1 sodium, I need 1 chlorine. So that's the formula for sodium chloride, is NaCl. However, it gets a little bit more tricky once you deal with numbers larger than 1. So for example, I have iron plus 3 here, meaning that it's losing 3 electrons, and oxygen minus 2, meaning it's gaining 2 electrons. Well, the 3 and the 2 do not balance each other out. Okay, I know they're close, but that's not balanced. So what we have to do is we have to add more of the same ion until they become balanced. So for example, I notice here the 2 and the 3, okay, they're not the same. So I added another oxygen down here. Well, negative 2, notice I still added the negative 2 because one of these oxygen ions has a negative 2 charge. So it's negative 2 and negative 2. That's negative 4, and that's positive 3 if we had that one iron. That's still not balanced. So I add another iron. Well, you can see here I added another oxygen so that the total oxygens is a negative 6 charge, and then the total irons is a positive 6. So now the base number is the same. They cancel each other out. So in the end, I needed 2 irons. So that's why I wrote a little 2 over here below. And then I needed 3 oxygen. So that's why I wrote a little 3 below the oxygen. And that would be the correct formula for iron 3 oxide. Now this last one, iron 3 hydroxide, this uses a polyatomic ion. Again, a polyatomic ion is an ion that uses more than one atom. In this case, it's a group of, in this case, it's oxygen and hydrogen. So this is one unit. We count this as one thing together. Well, hydroxide has a negative 1 charge. Iron has a positive 3. So I had to add 2 more hydroxides to cancel out that negative or that positive 3. So this positive 3 here. Altogether, they're negative 3. The base number is the same. So I had to write it like this. There's only one iron, so I just wrote Fe. Then I wrote parentheses because I need 3 of this whole unit. So OH is, we're going to treat it like one thing. But to make sure we don't get it confused with anything else, we put in parentheses OH. Then we put a little 3 on the outside. And that's how you balance ionic compounds and their ratios.